Hello everyone, I want to show you my latest and biggest project. It's a CNC Plasma table. It has dimensions of 2 meters by 1 meter. Its plasma source is Stamos CNC 125H, which has power of 125 amps. The control cabinet is here. It's operated by my Plasma controller, which is a Polish brand of CNC controllers. The y-axis is driven by NEMA 34 stepper drivers, which are hybrid ones with encoders. It's working on the rack and pinion. It's typical gate rack and pinion because it was way cheaper than CNC rack and pinions. It has two motors, one on either side, so one here and one here. The x-axis, which is here, is driven by this belt using the NEMA 23 motors. The x-axis motor is over there, and the z-axis motor is over here. It's also driven by belt on the MGN rails. Both of the x-axis and the y-axis is driven by those rails, the supported rails. The control cabinet consists of two power supplies. Over here is the 60 volt power supply, and here is 12 volt power supply. This one is strictly for the motors. These are the motor drivers, and this one is for the electronics. Here are some converters. As you can see, they provide power. It's 5 and this is 24 volt. This provides 5 and 12 volts. 24 volts is for my Plasma. 12 volts is regulated for the other control units. Here is the PC, which controls the entire system. This is the main control panel with the switch on, and this is the button to start the PC. This is the power for the PC, and these are control lights to see whether the machine is working or the computer is working. The latest upgrade for this machine I did was to add of course the water table, because when I was working without it, all the dust and the debris from the cutting went all over the place. So as you can see on my CNC lathe, it's dirty, it's all the plasma cutting stuff. So it was the water table, which works very well, and overall reconstruction of the frame. The control cabinet was added, because before it was just in the plastic box. Now it's integrated in the machine. The water table drastically increased the quality of the cuts. Before I had a lot of draws and other slag on the cutting edge. As you can see, there's pretty much no draws, and this was cut using the default settings I had with this 2mm sheet of steel. And I'll show you how it looked like before. Before I had a lot of draws like this. You can see it's all the draws over here. It's very bad because you have to manually take it off, which takes a lot of time. The next upgrades consist of the cover for the main head, which is this one. I've got it built already. It covers all the parts in here, but I have to check what happened to my control unit, because it had over here it had lights that indicate the state of the machine, whether it is working, idle or had an error. It was driven by this wire, but I had some problems when testing. My control unit somehow broke, so I don't know what happened. I will have to check. This is the control unit. I built it myself. It's based on Arduino Nano. From what I remember, it takes signals from these motor drivers, whether they are in error or not, and then gets their state and decides whether it's an error or something, and breaks the safety line. When the safety line is broken, the entire machine stops. So same as with the emergency button as we have here, the same thing. This is on the right, this is the safety relay, this is the relay for the PC. I will show you later. And that's pretty much it. There's still some improvements to be done. I was about to make covers for the motors on the y-axis, but they turned out to be way more difficult than I thought. But overall, this project is pretty much in the 90% done. I will show you more videos of it once it's finished, or during the work, during the progress. For now, that's everything for today. Thank you for watching, and I will see you next time.